Here's another example of a system of linear equations in two variables. We've been solving these using what's called the addition elimination method. In that method, what we try to do is we try to create, in the coefficients for one of the variables, additive opposites. So what I really like to see is I like to see a situation where one of the coefficients for one variable is positive and the coefficient for that same variable in the other equation is negative. But unfortunately, I don't have that here, as I did in some previous problems we've looked at. Here, the coefficients for the x's are both positive. Here, the coefficients for the y's are both negative. So I need to make one of those positive if I concentrate, say, again on the y's. And the reason I might concentrate on the y's and try to eliminate the y is notice 4 is already the least common multiple for 2. So I wouldn't have to do anything to this equation if I can somehow transform the coefficient of the y in this equation into positive 4, into plus 4y. Well, wouldn't that be done by multiplying this entire equation by negative 2? Negative 2 times 3x is going to give me negative 6x. Negative 2 times minus 2y will be plus 4y. Negative 2 times negative 11 is 22. And now if I add this newly created equation to the original one, again, the y coefficients are now additive opposites. Those terms disappear. Negative 6x plus x is negative 5x. 22 plus negative 7 is 15. I've created a linear equation in one variable that I can now solve for x by dividing both sides by negative 5. So x equals negative 3. So negative 3 is the x value of the ordered pair that's a solution to each of those original equations. It's the solution to the system of linear equations in two variables. So let's put negative 3 in for x. And now we have a linear equation in one variable that we can solve for y. I'll add 3 to both sides. And now divide both sides by negative 4. And the ordered pair solution, the x value is negative 3, the y value is 1. If we plug those values in for x and y into both of those equations, they solve each of those equations. Graphically, that's the point where those lines would cross, the lines that correspond to these linear equations in two variables.